x equals negative 35, there are an infinite number of y's there. So that violates our rule of a function, which says that there must be only one y, one unique y per x. And as we can see here, no matter what x we choose, x equals 0, x equals negative 20, x equals 40, no matter what x we choose, there's always one unique y. And that's why both b and c are functions, which is why they pass the vertical line test. Okay, for 5 and 6, we're moving right along. We're cooking here. For 5, let's graph the equation y equals negative x plus 1. Now, what I like to tell my students is that we can, I always like to be able to visualize what the rise over the run is. Because remember, all of our equations take the form y equals m, which is our slope, x plus b, which is our y-intercept. So before we even start, let's just take a look at our equation here. It's y equals negative x plus 1. Well, what number can we think of as being in front of this x? We can think of a 1 as being in front of that x, right? Y equals negative 1x plus 1. And since I like to actually be able to see the rise and the run in my equation, I like to put that negative 1 over a denominator of 1. Because any whole number is equal to that same whole number divided by 1. Or 3 is equal to 3 over 1, for example. So in our case, what we just did was negative 1 is equal to negative 1 over 1, which now allows us to actually see the rise and the run. So let's see how useful this is for us. So our first step is we come up here and our first step will be to come up to our equation and look at the b, or the y-intercept, and then our second step will be to plot the slope. So our b is positive 1, so we'll come up 1, draw a point, and keeping our finger right there, what's our slope? Well, remember our slope is always rise over run, and right here I see that it's negative 1 over 1. So our rise will be, we'll go down here, that's our rise of negative 1, and then we'll go over to the right 1, and that's our run of positive 1. And we'll plot a point, and we will just draw our line right through those points, and we notice that we intersect N. 6, let's do the same thing. Well, we're kind of doing it in reverse. Write an equation that describes this line. Now, I want you guys to note that this is the only question on the review that asks you to write an equation that describes the line. I would highly, highly recommend you to practice more problems like this. So we know that our equation will take the form y equals mx plus b. So y equals, let's first measure our slope. And remember that our slope is rise over run. So we can pick any point on this linear function. I'll choose right here. And let's measure our rise. 1, 2. So our rise is 2 over 1. Our run is 1. So our slope is 2x plus, let's see what b is. 1, 2, 3. So it's a positive 3. So 2x plus 3. And there you have it. I would definitely accept that as an answer. So it was easy. Our first step was we found, I decided I like to write my equation from left to right, so that's why I went ahead and measured the slope first. And then I just inspected my graph to find out what our b was. And our b was positive 3. Number 7, write an equation for a line that is parallel to the line y equals 4x plus 2. Okay, well, here's where we kind of need to get a little bit cerebral here. Remember that our general form is y equals mx plus b, and that it's our slope that represents the angle of our line. It represents the rise over the run. So 4x, 2, 3, 1, 2, 3, 4. So a slope of 4x would look like this. Up 1, 2, 3, 4 over 1. So I just graphed 4x right there. Now, aren't there several lines that are parallel to this one, and this one, and this one, and they all have the same slope? Thus, they all have the same rise over run, which equals 4. Aren't there a lot of lines like this? This line that they're talking about happens to have the y-intercept of 2. And so all it's asking is write a line that is parallel to the line y equals 4x. Well, that word parallel is a giveaway that we're looking for a line that has the same slope but a different line. So 4x plus, plus 3 you could write. Number 8, kind of a similar thought process here. Notice that as we increase our slope, I'll draw y equals x, and let's draw y equals 2x. That'd be y equals 3x, and the reason I'm drawing these is to illustrate that as we increase our rise and our run, see here, rise of 1, run of 1. For y equals 2x, rise of 2, run of 1. It's not a very straight line. And for our 3x, rise of 3, run of 1. So that's 3 over 1. So as we increase that m, there's a little 1 right there. You can think of a 1 being right there. So as we increase that m, our line gets steeper. So what is another equation that we could write that has a line with a steeper slope than 2x? Well, I don't know. You could write one that's y equals 4x, or y equals y equals 5x, or y equals 500x. Because really what we're saying is we're looking for something that is steeper than just a rise of 2 and a run of 1. We're looking for, that's supposed to be a rise and that's supposed to be a run. So a 4x fits the bill, because that would be a rise of 4 and then a run of 1, which would be much steeper than a line with just a rise of 2 and a run of 1.